Hello, welcome to CM Square Learning Center. In today's Mathematics SL lessons, I'm going to study one past paper question for sigma notation. It's topic 1, sequences and series. And this is paper 1 long calculator questions. The first three terms of a geometric sequence are natural log x power 16, natural log x power 8, natural log x power 4, for x is greater than 0. Find the common ratio, part A. So the formula for finding the common ratio is un plus 1 divided by un. Let's say u2 divided by u1, or u3 divided by u2, or u4 divided by u3. They must be equal for a geometric sequence. So now we can use the formula to find the common ratio. Let's say second term divided by first term. Natural log x power 8 divided by natural log x power 16. So here, we have to use the laws of logarithms. Yeah, we can look at the formula booklet. It's all given on the formula booklet here. The first one, log A plus log B equals log A times B. Log A minus log B equals log A over B. The third one here, log A to the power R equals R times log A. So it's like put the power down here. We'll move the power of A to the front here. So I think we have to use the third rule here. Put the power down. Log A to the power R equals R times log A. And be careful, the R is only for A. Okay? It's not for the log A. Okay? If a bracket here with power R, you can't put the power down, okay? It's wrong. So do check the R is only for A only, okay? So now, actually, the power 8 is only for X, and the power 16 is only for X. So we can put it down, put the power down. 8 times natural log X divided by 16 times natural log X. And then can cancel the ln X, right? 8 times 2 is 16, so the answer is 1 over 2, 0.5 for the common ratio. Part B. Solve a sigma notation from k equals 1 to infinity. 2 power 5 minus k, natural log x equals 64. So for sigma notation means sum of these number of terms. So let's expand the sigma notation to see how many terms there are. We can sub k equals 1. So the first term will be 2 power 5 minus 1, 2 power 4, natural log x. The second term is 2 power 5 minus 2, so 2 power 3, natural log x. And 2 power 2, natural log x. And the last term will be 2 power 5 minus infinity, natural log x. And the answer equals 64. That means if we add that up, adding all these terms together, and that equals 64. So that means sum of n terms, right? But how many terms here? Actually, there are infinite terms, right? It's sum of infinite geometric sequence. That's U1, the first term. And the common ratio, you see, 2 power 4 to 2 power 3, 2 power 2, right? So the common ratio is 1 over 2, 0.5, right? So for sum of infinite geometric sequence, we can find the formula from the formula booklet here. Sum of infinite geometric sequence equals u1 divided by 1 minus r. But the limitation is the absolute value for the common ratio must be smaller than 1. So what's meant by absolute value of common ratio? Right? Smaller than 1. So absolute value means we just look at the magnitude of the numbers, but not the sign. Let's say when the common ratio equals -2. So the absolute value for the common ratio is 2, right? 2. 2 is not smaller than 1. So we can't use the sum of infinite geometric sequence when there's a geometric sequence with a common ratio, and that absolute value for the common ratio is not smaller than 1, right? But the common ratio is 0.5, so we can use the sum of infinite geometric sequence formula. U1 divided by 1 minus R, and that equals to 64 is an equation here. And now we can sub it back. u1 is 2 power 4 dash log x, and the common ratio is 0.5, right? So times it by 0.5, 64 times 0.5 is 42, and 2 power 4 dash log x. 2 to the power 4 is 16, and 42 divided by 16 is 2 dash log x. So how to cancel a dash log, right? Dash log means log with base e, so we can add e from both sides. E to the power ln x, it cancels out, and e to the power 2. So x equal e squared. That's all.